Hello, and welcome to Exploring Axon, a podcast where we discuss Axon Framework, Axon Server, and their ecosystem. I am your host and a software developer at Axonic, Sarah Torrey. This is part 2 of my talk with Simon and Jan. I hope you enjoy the rest of this discussion, and let's have a listen. You said something that sort of stuck with me when we were discussing this topic. You were saying that one of the interesting phenomena in the microservices context is the idea of the independency and autonomy of the teams. Can you tell me a little bit about that? Can you
I think
elaborate?
this is interesting. I think it's one of the main reason why this microservices as a subject. Building distributed system is nothing new. We invented like 5 years ago or 10 years ago.
Right.
We were doing it all the
It's been
time.
around for a while. Yeah.
Yeah, and so it's and we knew all the time it's very hard because it's distributed, because you have concurrency problems, you have synchronizations problems, you have data inconsistency, and so on and so on.
Right.
But I think what evolved a lot in the last 10 years was the idea of how the projects are run and how complex projects are run.
Right.
And so that is this idea of that you have to divide complexity into pieces in some way, and there is a scope where basically there is a natural size of something you can build with a team,
Yes.
and you cannot go beyond that. So
Right.
it doesn't really make sense. So you can do it sequentially, of course, but at some point, if you're just only building it, you can go sequentially and build stuff in addition and addition and addition. But
Right.
if you have to run it, there is a natural boundary. So
Yeah.
if you're running what you're building, there is a natural boundary what you need to build, and you can vary with a framework and be a little bit flexible with this. But at some point, you have to just stop and say, okay, we need another team, and there should be another system.
Right.
And
Right.
this is the main idea that drives this microservice. It's not about micro how much code it is how big is the team that is responsible for it.
Gotcha.
And I think the key idea is that you should never share responsibility on system operations with someone else. So
Yeah.
it's okay that if you have two systems in a team, but it's not okay to be responsible for half of the system. This doesn't work.
Yeah.
And
You have, huh?
yeah, yeah, you have it right. It's
Yeah.
yours. It's now
Yeah,
your turn now. I was
Yeah.
last time.
exactly.
Okay. Oh, it's broken. Okay, now we have a
Flip
downtime.
the
Okay.
coin, right?
Yeah, exactly. So this
Exactly.
is exactly not going to work. So and this is very interesting because that leads us to this kind of autonomy on one side. So teams should be independent and should be able to act independent and work independent, and not
Yeah.
rely on other teams very strongly. So and this creates. So now you have the kind of Conway's law, which is inverted in this case, because
Right.
now if teams are independent, then the software components will become independent, and so it will follow. And so uh, this creates the need for creation of systems which are loosely coupled, and
Yeah.
it
Yeah.
gives all this CQRS and Axon framework such a foundation that today
Yeah.
you can say, okay, I accept eventually consistency, I accept the complexity of distributed systems, because there is no way to go otherwise.
Yeah. 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 Exactly. And you did mention different systems and how we want to structure them, which brings me to the next topic that I had in mind, which is the architecture of Axon. Can you talk about that? Either I think Simon, would you
Yeah,
pick that up since you
yeah.
were mentioning that? Yeah.
Actually very interesting, because Axon frameworks provide us kind of a system design that is sort of perforated for distribution, because you have these buses, and of course bus is an explicit communication point, so you can separate on the bus, right?
Right.
uh, so usually it's, by the way, a very good idea, and this is, I think, everyone should follow this idea. Start monolithic and get distributed later. So don't start it.
Mm-hmm. Mm-hmm.
Don't start, especially if you're new to all these concepts of
Yeah.
DDD, CQRS, messaging, Axon, whatever. You name the technology, but if you're new in it, starting with distribution on day one is very, very difficult because
Right.
not gonna perform.
Mm.
It's the wrong way. And
Gotcha.
uh, so but it's at some point you will be mature enough in this technology stack, and you will decide to that we you split up certain parts of your application to isolated parts and connect them via buses and so on. And
Yeah.
by the way, there must be good reasons to do so. It's not just
Right.
just wait until I'm 18 and then I go and get drunk finally. It's it should be like that, right? Yeah, so it should be a good reason why to separate certain parts.
Sure. Sure.
Uh, and
So you're saying
this
you need a good
separation,
reason to get drunk, right?
you
Nope,
said
that's a good
that.
reason to get right. But then in this case, I understand, that you start simple,
Yeah,
and then you basically add to it as you go, and separate the systems as you go. So for instance, there's a blog that I'm working on with one of my colleagues, and we're talking about going from modeling to actually the code source, and then coming back and looking at it from a higher top. And
yeah,
one of the things that we're discussing in that model is um, the idea is a music application, something that you can book music lessons with, and then that would be your first system. So you start with that system. It can be a monolithic system. You start with that, where you can basically just book a lesson simply, and have the students make changes, or your manager make changes, and so forth. And then down the road, when you decide that, okay, I want to add more stuff to it, I want to add another system to it, for instance, for the teacher to be able to have access to his or her lessons, and then have some sort of autonomy and what he or she wants to do in this system, then you add to it, and then you can basically then take those systems and break them down even further. So that's a really good example that you mentioned. You start big, and you start with that main idea, and as you go on, you decide what you want to do, whether you want to add to it, whether you want to take away from it. Then it becomes a little bit easier as you become more familiar with the business logic, basically, right? What you're trying to achieve from this business. But yeah, that was an interesting point that you raised. I think that's important for everybody to really start with that one idea, and then add to it as they go on. So, but yes, please go on.
yeah. I think
Little
it's very
track.
interesting. So I'm following you on your blog, on your project. So I'm
Yay!
really excited
Okay,
what you
right.
do there. I think we have to. There is a small challenge here. So there are two
Hmm.
different classifications we found, and
Mm-hmm.
they they kind of sound similar, and you can think it's the same, but they're not.
Mm-hmm.
And one being deployment strategies, and this
Yeah.
is actually how you distribute it. And
Mm-hmm.
the
Right.
second one being operation modes. And
Yeah.
maybe just give me some minutes, and we will come later to it, or maybe Jan will
Yeah.
tell us
Definitely.
about that.
Yeah.
So the point is that building software with Axon, if you do this business logic, this is kind of, there is your blog, and there is your podcast, and if you listen to this, you will learn how to build the business part of the application, especially.
Sure. Mm-hmm.
Um, but there are still many choices you have to make, and
Absolutely. Yeah.
and it starts with where what kind of, I mean, just to name a few, you're deciding what kind of data persistence technology you're using. Are you using event sourcing? Are you using data state sourcing?
Mm-hmm.
What kind of event store are you using? Is it GPA, so just a regular database, or is it
Mm-hmm.
MongoDB, or is it an Axon server?
Mm-hmm.
Or what kind? How do you build these query models? So are
Right.
they persistent or not, for example? And
Mm-hmm.
what's about buses? Are they distributed or not? And how to distribute them? So there is a solution from Axon server. You can build your own. There are different ways of doing, and then
Mm-hmm.
this is kind of this plumbing, which is
Right.
very well separated from the entire business logic, but you have to
Right.
deal with it if it grows bigger, right?
Yeah.
And
Exactly.
in the same time, all these questions are actually not, they're not asked in the just just to be answered somehow, but you
Hmm.
have some non-functional requirements, right? So your
Right.
system
Right.
should behave how you want to behave, independent from your business
Hmm.
part, from your functional stuff.
Exactly.
And so it's about throughput, it's about scalability, it's about how easy it's to operate, right? So I can,
Hmm.
use 25 technologies to distribute my events, but then I have
Right.
25 messaging technologies, and there must be operation team being able to do that.
Yeah.
um, there are security aspects, so
Exactly.
especially if we are writing data forever
Hmm.
in event store, append only event store, it's important how we deal with that.
Exactly.
And so uh, starting, or basically making these decisions lead up to these two classifications,
Hmm.
for
Yes.
the operation modes and for deployment strategies.
Exactly.
And um, we detected that there are some combinations of them where it can be a little bit harmful if you are not
Right.
paying attention to what you're doing.
Exactly. Right.
Especially if you say there is not one team responsible for building all this and distributing it, but there are several teams in
Hmm.
charge.
Hmm.
And
Yeah.
then you have this natural boundary of communication between teams, which means
Right.
that, just by using a specific operation mode and having independent deployment, put
Hmm.
people in a certain or give them a certain expectation
Right.
regarding the behavior of their system and the other part. And this must be communicated very clear what is meant
Exactly.
there.
Right.
um,
Right.
so I think you have to a little bit keep track on that, because
Hmm.
there are things that can go wrong.
I'm sure many things can go wrong. Absolutely. So let's then. I love that you put them in two different modes basically. So you have the operation modes, and then we'll talk about deployment strategies a little bit later. But Jan, can you tell me a little bit about operation mode? What is that? What do you mean by that?
Yeah, sure, happy to. Yeah, operation mode. I mean, you have to name things. We already discussed how important it is to put
Right.
explicit name to things. You,
Define them. Yeah.
yeah, define them just to you can talk about them and everyone knows what
Right.
you mean. And operation mode is our suggestion how we want to name these. It's we have those 5 message types and the distributed
Hmm.
communication
Right.
earlier.
Yeah.
And now we're building systems, and systems want to be part of this message event command communication. And
Hmm.
um, yeah, when you start monolithic, Simon said that's not that important to you, because you
Right.
just have this one system with an Axon framework dependency and maybe an Axon server connection, and
Right.
you're happy to go. Um,
Hmm.
but when you distribute certain aspects of those 5 message um, types we discussed earlier, then yeah, your system takes a role or has an operation mode. So a way it wants to be part of this distributed Axon
Hmm.
application. And we came up with 6. So I think
Hmm.
the warm-up, as Simon said, they were invented. I think that they were discovered. Um,
Yeah.
Let me so from the right side. So the I am storing the data and implementing the business
Hmm.
logic, the command
Right.
side. Of
Right.
course, I have the I have this operation mode where I am a system that manages an aggregate. So I'm responsible for managing consistent state. Uh,
Right.
I implement command handlers so I can react to intents sent to me.
Hmm.
And for this example, we consider that we already decided to do event sourcing. So we have an event
Hmm.
store keeping events.
Right.
This is all my responsibility. So this system doing this has to provide or register command handlers to
Right.
command bus, and has
Hmm.
to publish to the event bus and read from the event bus, because I have to
Right.
restore my aggregate state based on the events stored in the event.
Hmm.
So command model is this first and central operation mode. Without this command model, I would never have any state in my application. Then
Right. Yeah.
could be the same system providing this. Could be another system. I have a command client, of course, so I need someone who dispatches commands to those command handlers. Typically, when you build this monolithic, you would have, I don't know, a Kafka handler or a REST post interface where you translate the request coming from the outside to a command, just forwarding it.
Right.
But in our project, we have scenarios where we say, okay, I want to do this external post, but I don't want to be a system that knows about aggregates and command handlers at all. I just want to publish or dispatch a command to the model. So, and
Right.
the third component we have on this right side is the orchestration. So when it comes to working with multiple aggregates and command models, I introduce this concept of a saga. So yeah, there's something exactly. There's something that yeah, works as a command client and also as an orchestrator to combine those functionalities. So this is changing state, applying commands. And on the read side, of course, we have again as a command model, we have a query model. So this is my model where I receive domain events from the event store, and I'm building a custom projection. So the read model where I say here is the data I represent,
Right.
and you can query it. So and this system is of course registered to the event bus because it has to read events. It probably has its own token store because in case it's tracking, and it's very sensible way of doing it to be
Right.
just keep your token in the stream and know where you are. And a query model, of course, has to. The purpose is to answer queries, so it is registered to the query bus, and
Right.
so it could also provide REST GET interfaces, but those are the buses. So query model needs event bus, token store, and query bus.
Great.
And then
Gotcha.
we have a completely separated operation mode or even system that uses just this query bus. So I just know that some colleagues built a system, and the system registered a query handler
Right.
to answer a certain problem, current amount, to stick to the bank example. And I don't want to know anything about it. I don't want to send changes to it, or keep my custom projection or a token where am I in the stream. I just want to say this is my query. Please send me a result. So this is completely separated. And yeah, the sixth operation mode from this, the third one from the read side, might sound a little artificial. It's just event subscriber. So you're connected to the event bus. You probably don't even track where you are on the event bus. You're just reacting to any changes, which
Gotcha.
could be useful for tracing, monitoring, logging, but also for some bridging, where you'd say whatever happens inside my Axon system context, I listen to it and propagate it
Right.
to the outside to some other messaging component.
And of course, in real life, it's not so beautifully, clear cut. These are just. I think you mentioned something like these are like little Lego bricks. You
Yeah,
pick and choose whichever you want sometimes,
exactly.
and
So
sometimes you can't use all of them. Yeah.
the clear cut, of course, is just meant to it was our approach to just say these are six different aspects that
Yeah.
you should be able to support them separately. Although in practical programming, you, except maybe for this external query client, you most of the time will have at least two, maybe three of them connected. But that's when
Yeah.
it comes to those roles, you have to name them, you have to accept they are there, and you have to at least be able to say, I acknowledge that there is a system that just wants to send a writing intent to my system. Therefore, it does not need query buses. It does not need event buses. It doesn't need any local event store. And yes,
Yeah.
it's very.
Yeah, it's interesting to really have those ideas, the clear ideas of how should be separated or how you want to classify them, which is great. And but I understand in Spring auto configuration, these aspects are a little bit hard to separate. Can you talk a little bit about that?
Yeah, it's in Spring you have this wonderful feature that just by having some libraries on your class path, so the way Java JVM application loads its code dependencies, um, that Spring boot auto configuration then just says, okay, I see there is an implementation for the event bus present just in your code dependencies. So I configure this event bus for you, and I will connect it to the Axon server. So just by pulling in one Spring dependency or Axon framework Spring dependency, my system um, just becomes or takes the operation mode of, for
Right.
example, the external query client or even query model. Although maybe I never wanted to do so. So,
Yeah.
and this is it's possible with if you don't use Spring Auto configuration, just to use the custom Axon configurer and set up only the parts you need.
Yes.
But it goes deeper because on the Axon framework libraries, so the other things are building Lego bricks, and these are even
Yeah.
smaller Lego bricks, so to say. Um,
Yeah.
if, if if I'm a developer and I import a package and I have two interfaces, one is event bus, one is command bus, then I have to know that in my configuration I did not configure the command bus because I just need the event bus, but both are present. So when I do coding, um, my IDE suggests that I can use both, although I
Right.
know that I shouldn't. And those are
Yeah.
always the dangerous parts because you can do this architecture definitions,
Right.
deployment strategy, operation modes. If you um, if you have a team, let's say larger than two people, I think two people might be able to agree on some restrictions, and then you have to
Sometimes.
yeah,
Yeah.
sometimes yeah. Then you have to find ways to enforce the proper usage of these architectural and operation decisions you
Right.
made. And you can do code reviews. You can use some Sonar rules to say, hey, you shouldn't never import an event bus because we are just a command client.
Right.
But developers will always find a way
To go around it.
to go around
Yes.
it. It's sometimes it's most fun of programming, and it happens by accident. So, I mean, maybe just to we discussed this further before that we wanted to build a monolithic system. Don't start with distribution, but building the system in a way that we later can distribute.
Right.
That sounds amazing, but if if you have if you started building a system like your music library and you
Yeah.
said, okay, I have a synchronous REST request getting to a controller. This controller is forwarded to the service talks to a repository, and synchronous in the same transaction, I have a return pass up to the controller and your browser displays. If you start building your system like this, it's very hard later to say, okay, now let's separate this aspect, because
Right.
internally, although you have from the outside, you say we follow these great principles and we have everything loosely coupled, and but your system, the moment your service calls the repository, it relies on this happens now in the same
Right.
thread in the same transaction, and building systems in a way that even if you build them in a monolithic approach, internally cut in domains, contexts, building blocks that only communicate through the buses, is, I think, it's the only proper way of being prepared for this evolutionary development of microservices. But it's really hard again from the practitioner side to motivate this to your team colleagues,
Absolutely.
because
Yeah.
if you do, you can in the IDE you can follow the call chain from the controller to the repository and up. You can debug it step by step. You can write simple tests for it. If on all these levels you have just a bus that takes a command and publishes somewhere, and eventually a few milliseconds later there will arrive a result stating that is success or not successful, and you put this in your monolithic application. Um,
Right.
yeah, be prepared to have some discussion.
Some fun. Some exciting times.
But still, it's, if you want to be prepared, to keep so to be able to take defined operation modes, take defined role in this world, then I think this is a pain we have to get, even when we do monolithic. Um, so when we now maybe come to the deployment strategies, because monolithic always sounds that simple, and of course it is the simplest one, because I just you mentioned the Spring Boot dependency. I just put everything in one jar. I
Yeah.
press play on tape. I execute it, and it runs and works. But even in a monolithic system, I have to be aware of those feature and domain
Sure.
boundaries and these operation modes. Otherwise, I just get this internal, maybe not the big ball of mud, but the middle
Mess.
sized ball of mud
Yes.
mess. And then it's really
Exactly.
hard, because I mean I have this now in a system where we said, okay, this was a green field and everything was cool, and we built it with module separation internally. And the idea was, hey, later we can just take this part out and put it in another system. But it
Right.
happens so fast with modules
Often. Yeah. Yeah. Yeah.
often, that now component A uses an interface of component B, and component C requires transactional synchronous answer from component A. So yeah, this is really the greatest challenge in this monolithic evolutionary start
Right.
in one system. And you promote it as distribute later, but you're distributing,
Sometimes it's hard. Yeah.
basically you're distributing from day one in your monolithic
Sure.
system. And
Right. Right.
the Axon feature just grants you the promise that if you do this later, at least with Axon server, you won't notice any difference. You can just start the same application twice, disable module A and on the first node, and disable system B, feature B on the second, and they still work the same, because they're connected through the same buses they always used. But the hardest thing is get your colleagues to see the beauty of this, and
To get on board. Yeah.
the additional
Exactly.
uh,
Exactly. Now you talked about the deployments. Can you give me some examples of these deployment strategies that you use?
Yeah, let me jump in here.
Sure.
So, as Jan said, or as me said previously too, so it's a good idea to start non-distributed.
Right.
So having one deployment actually, which means that you will have anything together. So we, which means from the in terms of library, it means that you can actually act in any kind of operation modes, or
Right.
all the operation modes are inside of your application. And we still see how this evolution, or basically what parts can be inside of your distributed system if you come from this single system design. So let us start simply. So we call it monolithic core. So
Sure.
as we were speaking about CQRS, which is the command and query segregation. Uh,
Mm-hmm.
this segregation is internal. Okay, so you
Right.
just do you just don't connect the read side and the write side directly, but you're
Mm-hmm.
using an event bus for that,
Mm-hmm.
which means that you have your command side of your business model, of your domain model, which is formed by the aggregates and the entities,
Mm-hmm.
and then you have the query side, which is built by the projection.
Right.
And yeah, so if you have, like, if your system is like symmetric in terms of reads and write,
Mm-hmm.
in terms of that, you're not a like a queue where you put data from one side and get completely different data on the other side produced. But
Mm-hmm.
if you are interested in writing data and then reading it data later on,
Sort of like a
um,
one-on-one
yeah, then you have
relationship.
this,
Yeah.
it's kind of natural to have it together. And
Right.
this component, so this system will use all five type of messages, of course.
Mm-hmm. Mm-hmm.
um, and sometimes you need you have more than one aggregate, then you will have some saga, so you will need some
Mm-hmm.
orchestration between them, and sometimes not, but this is still what we call monolithic core.
Right.
Then one of the first thing that happen if you get to this non-functional requirement of higher throughput,
Mm-hmm.
which especially happens a lot in the internet use cases, where the read side is much more frequent than the write side. Okay,
Right.
so you have some people writing stuff and much more people reading stuff. Okay,
Mm-hmm. Mm-hmm.
so you kind of more than like the facts are so crucial that everyone wants to know.
Yeah.
Okay, and that means that if from the performance and throughput point of view you want to
Mm-hmm.
scale up, then you don't need to scale up both sides, right? So the
Mm-hmm.
command model can remain as it is. So there it's about consistency. You have maybe some fail over strategy, so there are like two components of them.
Mm-hmm.
The read side is used in a high load manner, so you need maybe 5 deployments of that. Okay, so this
Right.
is the kind of distributed core idea. So
Mm-hmm.
you
Mm-hmm.
still have the core application; it's your core business, but you just cut the piece of your subdomain or your domain basically in pieces and say, okay, I do this segregation exactly like CQRS proposes this to do.
Mm-hmm.
Um, then there is another one, and there is a difference to that. So here we were speaking about the same concept from the business and
Right.
separating the read and the write side of it, so the command and the
Mm-hmm.
query side.
Sure.
A little bit different to this is what we call additional projection. So this is
Mm-hmm.
what you follow, what you mentioned in your example. Like
Right.
I have someone else who wants just information about this,
Mm-hmm.
and it's just so you have your so still your core monolithic or
Mm-hmm.
distributed, it doesn't matter,
Right.
with your core concept, and now you get a new use case where you say, okay, I can deduce some new way how this data can be received and how it
Mm-hmm.
should be stored. So I
Right.
build this new projection and connect this to existing core without introducing new aggregates and new domain concepts.
Right.
And this happens a lot. Yeah, so there can be two driving forces for this. So either someone is creating just the interface to you and says, okay, you almost have what I have, what I want to have, but a slightly different way,
Right.
or you just providing new functionality.
Mm-hmm.
And then we see that there is this pure orchestration. So we come from business process modeling, so it's kind of our passion to speak about this and to do
Yeah.
this. So we think that there can be this one thing. So if you're not as much about data in your
Mm-hmm.
core concept modeled by the aggregates,
Right.
but if it's about the you know state change that drives some kind of a policy or in the
Mm-hmm.
process. Okay, so then they were speaking about orchestration components. So you have to coordinate how the state change is executed among several aggregates, and this can
Mm-hmm.
be pretty complex. So the
Yeah.
whole area of business process management is doing exactly that. And
Mm-hmm.
then it's a good idea to separate this orchestration. So there, the split you do in your domain
Mm-hmm.
is to separate orchestration from functional components,
Mhm.
because there is a kind of rule of thumb. Then the orchestration changes more frequently than functional components, and
Right.
that's the reason why you say, okay, I built some functional components, and later on I can define different orchestration doing the same actually
Mhm. Mhm.
functional stuff. Okay,
Yeah.
so
Yeah.
again, this idea of having building blocks and splitting complexity and reducing complexity by applying divide and conquer actually.
Mhm.
So there
Mhm.
can be this
Makes sense.
orchestration deployed independently,
Right.
and so these are the kind of deployment strategies we see. So
Mhm.
how, or maybe it's more motivation. So why should you
Right.
distribute, right?
Yeah. Yeah. Exactly. So this all sounds pretty clear. Is there a problem? I'm sure there are challenges.
Yeah, I think the problem is that if you start from the deployment strategies, you can say that it should be the way that you can say, okay, if I have a deployment strategy
Mhm.
in mind, then I should be able to say for each component in which operation mode it is.
Mhm.
And actually, it's as Jan said, there is no way to really enforce it for now.
Right.
So exactly this phenomena of Axon framework being able to
Mhm.
randomly distribute these components and connect them again
Yeah.
um, is not restrictive enough in this way to say that if you distribute and if you decided that this is an additional, for example, an additional projection,
Mhm.
you still can create an aggregate inside of this component
Mhm.
and
Mhm.
fire commands or dispatch
Right.
commands, right?
Right.
And change
Right. Right.
state.
Yeah.
And this is kind of, this makes it a little bit blurry, and the
Mhm.
responsibilities of the systems and the purpose of the systems
Right.
um, becomes unclear, and they're kind of weakening,
Mhm.
and this is introducing this uh, basically allowing this quick and dirty hacks to say,
Yeah. Yeah.
okay, I just we should do it like that, but actually,
Mhm.
I can do it here.
Right.
and
Right.
and this is the kind of experience from these large projects. Every time you do
Mhm.
this, like sometimes it's a month later, sometimes it's a half a year later, and if you are unlucky, it's 2 years later.
They'll come back to bite you.
Yes,
Yeah.
and it will. And the longer the distance is, the more
The
the
harder.
more the
Yeah.
more painful it is in the end. Yes.
Exactly. Yeah. Yeah. I
So
can
actually,
imagine.
this quick and dirty hack is then something that kills you sometimes.
Right. Right. Exactly. Yeah. And what do you think, Jan? I think you
So,
have some back.
yeah, if I might add, the longer the distance is, again, what I said, it's hard to communicate this to a team.
Sure.
Uh, the longer
Hmm.
the distance is between the mistake and the consequences, the longer
Yeah.
period where you cannot really argue pro separation, pro keeping
Right.
this structure, because other people proved it works, right?
Hmm.
So,
Hmm.
failing fast is not only less painful to fix it, although the only way to get progress in this direction, because otherwise, yeah, you have this big explosion, hopefully in this half, or in Sutton's half of the system, um,
Yeah.
where you just cannot do it anymore. And then maybe this is a moment where we start greenfield and use a new
Hmm.
technology and a new system.
Hmm.
So this is clearly something we do not want to um,
Have to deal with. Yeah.
yeah, and I think this is not a problem. I mean, it sounds now as if this would be a problem of Axon itself.
Hmm.
Everyone else is doing fine. This is a general problem of this
Hmm.
distributions. I think
Hmm.
the
Hmm.
only infrastructure that has a really strict and correct model for this are databases, because I have a database and I say I grant this operation to this
Hmm.
table to this group of
Right.
users are responsible, and I don't have this on Rabbit or Kafka, or I just say you are allowed to listen to this topic and you are allowed to
Hmm.
publish to this topic. Maybe you
Hmm.
have a restriction what messages are possible on this topic, then I get maybe some more restrictive feature, but otherwise I cannot prevent anyone from who's able to read from a topic just to publish anything. And this is not really
Right.
Axon specific, but distribution specific. And the only level where we really have this fine granular management is the only level we do not distribute, because I think there we could do this separate grants, but there we have the rule: no one else reads my database, and I just get all rights for my application, and we're done. So this is
Yeah.
a mismatch, and maybe we can, so Axon server has, at least the enterprise edition has this ACL to at least configure that my system is able to dispatch commands, or is
Right.
not able to dispatch command, but it doesn't allow me to decide which commands. So maybe
I see.
I have a system where I say, okay, you can create contracts. Someone takes data, telephone, whatever, and then I send a create contract command. But this system should never be able to, I don't know, alter positions, or change the customer's address, whatever. Maybe
Right.
really poorly cut context that I created now. So this is something that, yeah, might be missing and interesting to discuss. I think we are on it with Alat and Stephen.
Yeah. Yeah.
Um,
Definitely.
so yeah, just from this
Yeah. Something to work on. Yeah, definitely some adjustments can be made there. But I understand that you did a couple of things to solve these issues. Can you talk a little bit about that, Jan?
yeah, happy to. So as we already stressed, that in an ideal world, we would have this Lego bricks and start
Mm-hmm.
building an application that has two or three of these operation modes by putting together those bricks. And we already discussed that the auto configuration just gives me this: you can do everything. So
Mm-hmm.
unfortunately, I cannot build the system by adding things up. I have to build the system
Mm-hmm.
by removing parts. So I get,
Right.
yeah, and this is what we did. Now we have, I think, a still private repo, but we could really put this out and discuss it on GitHub, and something I did in my customers project as well. So basically, you say, okay, you have access. You can just use a command gateway. I cannot prevent this. This is how the system is built. But what you can do is fail fast. So you implement a fake
Mm-hmm.
command bus, so to say, that just
Yeah.
fires exceptions and says you are not allowed to do this. So
Right.
what I built is, you take the Axon server auto configuration. You say I am a system using Axon framework connecting to Axon
Mm-hmm.
server, and then by
Right.
additional annotations, you say, but I am in the query only mode, which
Mm-hmm.
prevents the system using this mode from creating a Saga store table, a token store
Nice.
table, and it does not prevent you from having a command bus.
Right.
But if you use this command bus, you will fail immediately, because the only implementation
Ah,
available to your system is the one that says you must not use me. And
right.
this is something that is not that complicated to build, based on the
Mhm.
Spring auto configuration,
Right.
conditional configuration, and yeah, we're discussing this with Stephen right now, how to yeah,
Mhm.
how
Gotcha.
this can be done. I mean, we have this community extension model. It doesn't have to become part of any core, but yeah,
Right.
this is work in progress and really interesting. And yeah, the other thing I mentioned already, we use the Axon enterprise servers, so
Server.
we
Mhm.
can to a certain extent, not enough for what I really want to do, but to a certain
Mhm.
extent, we can use this access management on the server and say your
Right.
system, even if you would have access to real command bus implementations that would allow you to publish events,
Yeah.
I configured your system that you are not allowed to do so at all.
Mm-hmm.
But it's
Mm-hmm.
just
Mm-hmm.
0 and 1. I cannot say
Right.
you are almost not allowed to, but this one is okay. This is something I cannot
Mm-hmm.
do right now. But that's also something we use, and where the Axon framework and server provide features. So
Yeah. Yeah.
yeah, but still it
Very good.
remains everything you offer to the developer. He will at least try to use it. That's how we are.
Yeah, that's great. Yes, and that's why I really was interested in getting your point of view in terms of using, Axon Framework and Server and some of the other technologies that you've used, and some of the really cool concepts that you've come up with that you kindly shared with me today. So I really appreciate you taking the time and talking about this, and I really can't wait for this the soccer game application to come out, and I can take a look at it and play around with it. I haven't played table soccer since, gosh, my teen years. So I'm interested to give it a
Unfortunately,
go and see how it goes.
unfortunately, in 2020, we didn't play table soccer as well.
I know.
You
Yeah,
can just not keep a 1.5 meter distance with four
exactly.
people at a table soccer table. So
It's a big problem there. Yeah, exactly. And your office is actually not too far from my home. So maybe one of these days, after everything kind of gets back to normal, I can
just stop
drop in
by.
and have a tournament.
Of course, of
But
course.
we're an engineering company, so we were really discussing if is it
Oh,
possible
great.
to build kind of, maybe construction that you can pull on the table that you can still play, taking the distance. But yeah, there is a big
Yes.
sign saying stop now, and yeah,
Mhm.
so
But
Yeah.
but
health first, and it's important.
the good thing is it gives us time to finish the application. So
Yes.
Which, yeah, you got away from actually playing the game and got into building the application
So
for the game, which
currently,
is good.
the last success, what we have the pretty decent front end already for that, and
Hmm.
now we build up an
Nice.
end-to-end test. And
Yeah.
so if you're bored, you can just log in into the integration server and look how
Hmm.
a computer is playing with his own, randomly scoring on
That's
one side
great.
or another side, and it
I
proves
don't
that the game
I
is
don't have
running
to
all the
play
time.
myself anymore. I just can
Oh
watch the
no.
robots playing. Yeah.
Yes.
Okay. Perfect.
That's perfect. Oh, really cool, really exciting stuff. So, thank you both really so much for joining me this morning. This was such a really interesting topic to talk about, and I appreciate all of the information that you shared with me and our listeners. I really appreciate the time that you gave me today. I hope you have a fantastic day. It looks pretty great today, but hopefully not too rainy, and we'll enjoy the rest of the day. Thank you so much.
Yeah, thank you
Thank you,
very much.
Have
Sarah.
a great day. I hope you enjoyed my talk with Simon and Dion. This concludes our podcast series for the year 2020. To those of you who celebrate, happy holidays and happy new year. This past year was a challenging year for many of us, but I hope the new year brings us all health, happiness, and prosperity. I cannot wait to share more exciting topics with you next year. Until then, have a great time, stay healthy, be safe, and happy coding.